Hello everyone. We will now begin part 4 of our video solutions for project 3. We will begin with question number 10, which is on solving trigonometric equations. There are 3 parts to this question, 3 different equations that we have to solve. Part A is sine of 4x equals negative square root over 2 divided by 2. Now the question above says solve the given equations in the intervals 0, 2 pi. We have to make a note of the brackets around this interval. 0 is a closed interval. That means the value of x can be 0. 0 can be included in the set of solutions. However, 2 pi has a round bracket after it, which means it's an open interval. 2 pi should not be included in the set of solutions. You can get as close to 2 pi as possible, but it will not be 2 pi. That's how the interval is interpreted from the brackets surrounding it. All right. Now, the first question is sine of 4x equals negative square root over 2 by 2. We have to solve for x, not for x, but x. However, we will have to take into consideration 4x in the process of solving it. So let's begin by looking at the sign of the ratio given to us. It's negative square root over 2 by 2, and the trigonometric function is sine. We have to think in which quadrants sine would have a negative ratio. It would be in quadrant 3 and quadrant 4, correct? Not in quadrant 1. All ratios are positive there. In quadrant 2, sine has a positive ratio, so it must be in quadrant 3 and quadrant 4. So let's begin by writing that step down. We see that the sine ratio given to us is negative. Therefore, it could be an angle in quadrant 3 or in quadrant 4, correct? So we'll be looking for angles which are either quadrant 3 angles or quadrant 4. We will not consider quadrant 1 and quadrant 2 angles, just because the ratio given to us for sine is negative. The next step is to find for what angle would sine have a ratio of square root over 2 by 2. Forget about the negative sign at this time, all right? We know that sine of pi over 4 is square root over 2 by 2. Let's write that down next. So sine of pi by 4 in the first quadrant equals square root over 2 by 2. Why did we need to do this step? Because using pi over 4, we will be able to find the values of the third quadrant and the fourth quadrant angle. The formula to find the third quadrant angle given pi over 4 is a first quadrant angle would be, let's write that, for quadrant 3, the formula is pi plus pi over 4. You add pi to the first quadrant angle, which is pi over 4. That's the formula. You have to know that. It will not be given to you. Pi plus pi over 4 would give us the third quadrant angle, which would be equal to 5 pi over 4. Now, quadrant 4 angle has the formula 2 pi minus the first quadrant angle. So 2 pi minus the first quadrant angle is pi over 4. Therefore, it will be 7 pi over 4. So these are the 2 angles which would be within 0 and 2 pi for sine of x or sine of alpha, not for sine of 4x. You have to remember that. The angle value over here is written as 4 times x. If it was just sine of x or sine of alpha, solve for alpha, you would be done at this point. The solutions would be 5 pi over 4 and 7 pi over 4. The question has 4 times x and we are solving for x. Again, we are just dealing with the third quadrant and fourth quadrant angles. What we do is this 4x is really our alpha value. We equate 4x to 5 pi over 4. Let's start by finding the third quadrant angle. So 4x equals 5 pi over 4. We are solving for x. So multiply 5 pi over 4 by 1 over 4. Correct? You divide both sides by 4. So it'll be 5 pi over 4 times 1/4, which should give us 5 pi over 16. And that is the value of x. Let's write that here. X equals 5 pi over 16. That's one of the solution. In fact, that's the first solution in our set. All right, so let's go over the process one more time. We equate 4x to 5 pi over 4 and solve for x, right? Therefore, we came up with x equals 5 pi over 16. That was the value of x for the third quadrant angle. For the fourth quadrant angle, we have to equate 4x with 7 pi over 4. So again, divide both sides by 4. We will end up with x equals 7 pi over 4 multiplied by 1/4 would give us a value of x, which is 7 pi over 16. So those are the first two x values. However, it says x has to be within this interval 0, 2 pi. So you have to go around until you get to an x value which is as close to 32 pi over 16, but not 32 pi over 16. So you have to keep adding 2 pi to 5 pi over 16 and 7 pi over 16, and the final set of solutions will look like this. Let me give you the entire set of solutions. It'll start with 5 pi over 16, then the next one will be 7 pi over 16, then we'll have 13 pi over 16, we'll have 15 pi over 16, followed by 21 pi over 16, then 23 pi over 16, 29 pi over 16, and the last one will be 31 pi over 16, and you close your brackets. All right? So look at the last one. 31 pi over 16 gets us close to 32 pi over 16. 32 pi over 16 would be 2 pi. We cannot include 2 pi in our solutions, or cannot go over it. We can go as close to 2 pi as possible. Therefore, we will close at 31 pi over 16. So this is the entire set of solutions for x in the interval 0, 2 pi. Again, keep in mind that we are solving for x and not for x. All right, and that's why all these steps. All right, now let's work on the next trigonometric equation given to us in part B. It's 2 times sine squared x plus sine x minus 1 equal to 0. And we have to find the solutions within the interval 0, 2 pi. Now, as you can tell by looking at the equation, that this is a quadratic equation. It's an expression in quadratic form. Therefore, the first step would be to see if we can factor this out. So we have to factor 2 times sine squared x plus sine x minus 1. And I'm going to work it out on the side. 2 times sine squared x plus sine x minus 1. Now, if you find it difficult to factor with an expression like sine x, as a temporary step, equate sine x with a. So I'm going to write below, let a equal sine of x. So we rewrite 2 sine squared x plus sine x minus 1 as 2 times a squared plus a minus 1. It'll be easier to factor this way. And then at the end, we can go back and put sine of x wherever there is a in the factors. All right. I always like to use the grouping method when factoring trinomials. So using the grouping method, it would be 2a squared plus 2a minus 1. These are the 4 different terms that I get using the grouping method. Now we have to factor each of these pair of terms. So between 2a squared and plus 2a, the common factor is 2a. Within brackets, we have a plus 1. And then between negative a and negative 1, we factor out negative 1. That's the common factor. So it'll be negative 1, within brackets we will have a plus 1. The two factors eventually would be 2a minus 1 and then a plus 1. And then do not forget to put back sine x wherever there is a. We started by saying let a equal sine x. Please replace a by sine x, because this was just a temporary step to replace sine x by a to make the factoring process easier. That's all. So I'm going to write this as 2 times sine x minus 1 and sine x plus 1 as the two factors we got after completing the factoring process. So let's write here 2 times sine x minus 1 and sine x plus 1 equal to 0. We use the zero factor property to solve this. We make each of these factors equal to 0 and solve for x individually. So when we start solving it, we get 2 times sine x, bring the negative 1 over to the other side. It'll be a positive 1. Divide both sides by 2. We will have sine x equals positive 1/2. Now we have to figure out for what value of x would sine be a positive 1/2. There are two angles possible with ratios of positive half. It would either be a first quadrant angle or a second quadrant angle in which sine is positive. Correct? The sine ratio is positive. Now we know that in the first quadrant, sine of pi over 6 is 1/2. So one of the solutions would be x equals pi over 6. And that would be a quadrant 1 angle. To find the quadrant 2 angle, we have to use the formula to find a second quadrant angle using the first quadrant angle. The formula is pi minus whatever the first quadrant angle is, pi over 6, and that will give us 5 pi over 6. So for the second quadrant angle, x will have a value of 5 pi over 6. Now we will work with sine of x plus 1 equal to 0. We have sine of x plus 1, equate that to 0. We have to solve for x, move the plus 1 over to the other side. We'll have sine of x equals negative 1, right? When we move the plus 1 over to the other side, it becomes a negative 1. And now think about this. For what value of x is the sine function negative 1? Now, sine is negative in the third quadrant as well as in the fourth quadrant. But negative 1 is really a quadrantal angle. The sine of 3 pi over 2 is negative 1. And a quadrantal angle really falls between two quadrants. So for this solution, where sine of x plus 1 equal to 0, therefore sine x equals negative 1, x would be one solution, just 3 pi over 2, because it's a quadrantal angle. Therefore, the other solution of x will be 3 pi over 2. Therefore, the final set of solutions for this question would be x equals pi over 6, x equals 5 pi over 6, and x equals 3 pi over 2 between the interval 0 and 2 pi. So let's put it as a set. It would be x equals pi over 6, 5 pi over 6, and 3 pi over 2. All right, this is the final solution for this particular equation. All right. Now, the equation in part C of this question will require us to use some manipulation. So it's cot squared x times sine of x equals cot squared x. This is the equation we have to solve. What we have to do is we have cot squared x on both sides. Therefore, begin by dividing both sides by cot squared x. And when we do that, we divide on the left-hand side cot squared x and cot squared x divide, and we are left with sine of x. And what do we have on the right-hand side here too? Cot squared x and cot squared x divide. We are left with 1. So cot squared x divided by cot squared x equals 1. It is not 0. I see that mistake from time to time in some of your answers. But just remember that just like 5 divided by 5 is equal to 1, a divided by a is equal to 1. Cot squared x divided by cot squared x would be equal to 1, right? So on the right hand side we have a 1. Therefore, we get the equation as sine of x equal to 1. Now we have to find for what value of x would the sine ratio be? A positive 1. Sine of pi over 2 is equal to 1, which is again a quadrantal angle, right? Pi over 2 is a quadrantal angle between quadrant 1 and quadrant 2. It sits right between, in the middle of quadrant 1 and quadrant 2, correct? Therefore, we write sine of pi over 2 equals 1. Therefore, x will be equal to pi over 2. And there's just one solution for this problem. There's no other angle within 0 and 2 pi which would have a ratio for sine as positive 1. And that's the solution. So this went pretty fast. This is a relatively easy problem to solve, provided you realize that you have to perform some manipulation with the expressions in the initial equation given to us. All right? We will now work on question number 11, which is a word problem. Let's read through it first. It says 2 fire lookout stations are 10 miles apart with station B directly east of station A. Both stations spot a fire. The bearing of the fire from station A is north 25 degrees east, and the bearing of the fire from station B is north 56 degrees west. How far to the nearest tenth of a mile is the fire from each lookout station? The first step will be to draw a diagram using the description given here. We should be able to extract the form of a triangle from that diagram, and then we will be able to solve this problem. They're essentially asking for the distance between the fire and each of the 2 stations, right? So let's start here by drawing the diagram. It says station B is directly east of station A. So there are 2 lookout stations, station A and station B, and they are horizontally apart, and B is to the east of A. To the east of A would mean it is to the right of A. So let's mark the spots where A and B would be. Here is A, and then straight horizontally to the east would be station B. And they both spot a fire. So the fire is visible from both the stations. So let's mark it over here. And then it says the bearing of the fire from station A is north 25 degrees east. Now, how do we show north 25 degrees east? Draw a vertical dashed line through A, that's the north-south line that passes through point A, and it's north 25 degrees east means you go 25 degrees towards the right of this vertical line, and that angle between the north-south line and the line of sight to the fire from A is 25 degrees. So north 25 degrees east. Right, let's mark this point as a C. And then for B, it says the bearing of the fire from station B is north 56 degrees west. So for that, I'm going to draw another vertical line passing through B this time. And this angle made between the north-south line from B to the line of sight to the fire C is north 56 degrees west. So this angle is north 56 degrees west. West means the angle is formed going to the left from that north-south line, correct? So we have the angle values and the direction set, the bearing straight. and this is the distance between A and B. It says the two lookout stations are 10 miles apart. That tells us the distance between point A and point B would be 10 miles. So the question is, how far to the nearest tenth of a mile is the fire from each lookout station? So we have to solve two problems here. We have to find the distance between point A and point C, as well as the distance between point B and point C. Let's label the sides, all right? So opposite to angle A would be side A, opposite to angle B would be side B, and then opposite to angle C is the distance between A and B. So this is our side C. Now we see that this triangle is in no way a right angle triangle. It is an oblique triangle, and therefore we cannot use the trigonometric ratios of sine, cos, and tangent to find the distances. We have to use the law of sines. Whenever your triangle is not a right triangle, you will either use the law of sines or the law of cosines, as the case may be. All right. So essentially we have to find the length of side B and side A as well. Side B is the distance from A to C, and side A is the distance from point B to point C. Now, in order to do that, we need to find the internal angles of this triangle. We have the angles outside the triangles formed with the north-south line. We have to find the internal angles, angle A, angle B, and then angle C. If we know the measure of angle A and angle B, we can also find the measure of angle C. However, to find the measure of angle A, we have to subtract 25 degrees from 90 degrees because the north-south line forms a 90-degree angle with the horizontal line, the east-west line, right? So let's find angle A first. Angle A would be equal to 90 degrees minus 25 degrees, which is equal to 65 degrees. Therefore, this angle here, angle A, is 65 degrees. Then we have angle B. Angle B can also be found the same way as we did with angle A. It's 90 degrees minus 56 degrees. Let's write that. Angle B is equal to 90 degrees minus 56 degrees, which is equal to 34 degrees, right? This is 34 degrees. Now that we know the measure of two angles, we can find angle C by subtracting the sum of 65 and 34 from 180 degrees. Let's do that here. Angle C equals 180 degrees minus the sum of 65 degrees plus 34 degrees, which is equal to 81 degrees. 65 plus 34 is 99. 180 degrees minus 99 degrees is 81 degrees. So let's write 81 degrees for angle C. So now that we know the measures of the three angles and one side, we will go ahead and use the law of sines to find each of the other sides of the triangle. Let's start by finding side A, which is the distance from station B to C. So first we will deal with the side A. Find side A, which is the distance from station B to C. B to fire, right? So now we will form an equation using the law of sines. Now the equation must contain the unknown side, the angle opposite to it, and a known side and a known angle opposite to the known side. All right, so let's do that. The equation would be set up like this. It would be A divided by sine of A equals C divided by sine of C. So A is the unknown side, so it will be left as A. Angle A is 65 degrees, so it's sine 65 degrees equals side C is 10, so 10 over sine of C. Angle C is 81 degrees, therefore sine 81 degrees. All right, so let's proceed. We are solving for A Therefore, A would be equal to 10 divided by sine 81 degrees times sine 65 degrees, which is equal to, it's 10 times 0.9063. That's the value of sine of 65 degrees, and sine of 81 degrees is 0.9877. And when we perform this division, we will come up with 9.176 miles. So the distance between station B and the point where the fire is 9.176. So let's round it up, because the question said round it to the nearest tenth of a mile. It'll be 9.2 miles. We'll write the answer separately at the end. The next step is to find the distance from point A to point C, from station A to the fire. So it's the same process this time. We find side B, which is the distance from station A to fire C. What would the equation be? It has to have the unknown side in it. So B divided by sine of angle B equals C divided by sine of C. Angle B was equal to 34 degrees, so sine of 34 degrees equals side C is 10, and sine of C would be sine of 81 degrees. Solve for B. So we'll end up with 10 divided by sine of 81 degrees times sine 34 degrees. Next step is to find sine of 34 degrees is 0.5591. Sine of 81 degrees is 0.9877, which is 5.66 miles. Rounded to the nearest tenth, it would be 5.7 miles. All right, therefore, our two answers are from station B to fire is 9.2 miles rounded to the nearest tenth of a mile, and the other one, station A to the fire, is 5.7 miles. That's the final answer. So that is how you're going to go about solving these word problems, which are applications of the law of sines. We will now work on question number 12, which is on solving a triangle. They have given us the lengths of three sides of the triangle. We have to find the three angles of the triangle. Now, when we are given the length of three sides of a triangle, we will have to apply the law of cosines. All the three formulas will be first written out, and then we will pick the formulas one by one and solve for the different angles. So here on the side, let's write out the formulas first. As we know, there are three formulas pertaining to the law of cosines, one for each of the sides. We begin with a squared equals b squared plus c squared minus 2bc cos of a. B squared equals a squared plus c squared minus 2ac cos of b. And finally, we have c squared equals a squared plus b squared minus 2ab cos of c. We will begin by finding angle A first. Therefore, we have to choose the formula which has angle A in it, and that would be the first formula, a squared equals b squared plus c squared, and so on. So I will begin by rewriting this formula up front. It'll be easier for us to plug in the values correctly. Now that we have the formula written out, let's plug in the values. A squared would be 3 squared. B is 9, therefore b squared would be 9 squared, plus c is 8, therefore 8 squared, minus 2 times b is 9, c is 8, cos of a. Therefore, on the left-hand side, we have 3 squared is a 9, 9 squared is 81, plus 8 squared 64, minus 2 times 9 times 8 is 144, cos of a. Let's start solving for angle A by moving terms to the other side. We will have 9 minus 81 minus 64 on the left-hand side. On the right-hand side, it'll be negative 144 cos of a. Now, 9 minus 8 minus 64 should give us negative 136. On the other side of the equation, we have negative 144 cos of A. Divide both sides by negative 144. We end up with cos of A equals. Now, negative 136 divided by negative 144 simplifies to positive 17 over 18. At this point, we will be using the arccos function on our calculators to find the value of angle A. Angle A, whose cosine ratio is positive 17 over 18. And that should give us angle A having a value of 19.2 degrees rounded to the nearest tenth of a degree. Now that we have angle A, let's find angle B. We will use the second formula in the process. It's B squared equals A squared plus C squared minus 2AC cos of B. Let's write it out up front first. Let's plug in the values of the variables. B has a value of 9, therefore it will be 9 squared equals, A is 3, so A squared is 3 squared plus C is 8, therefore 8 squared minus 2 times 3 times 8 cos of B, which gives us 81 equals 9 plus 64 minus 48 cos of B. Let's start moving the terms to the other side to isolate cos of B. We will have 81 minus 9 minus 64 equals negative 48 cos of B on the right-hand side. On the left-hand side, we have 8. 81 minus 9 minus 64 is positive 8 equals negative 48 cos of B. Let's divide both sides by negative 48. We end up with cos of B having the ratio negative 1/6. And once we use the arccos function on our calculators, we will come up with angle B having a measure of 99.6 degrees rounded to the nearest tenth of a degree. So now we have found the value of angle A. We found the value of angle B. We need to find the value of angle C. For that, we do not need to apply a law of cosine's formula. We can simply add up the measures of angle A and angle B and subtract that from 180 degrees, correct? So let's do that. Angle C will be equal to 180 degrees minus 19.2 degrees plus 99.6 degrees. When you complete this calculation, you should come up with an angle measure of 61.2 degrees. Therefore, angle C will have a value of 61.2 degrees. And here we have found all the three angles of the triangle with the given sides of A equals 3, B equals 9, and C equals 8. All right? We will now work on part B of question number 12, which is a problem on solving triangles as well. The information given to us is that the length of side A in the triangle is 4 units, that of C has a length of 7 units, and angle B has a measure of 55 degrees. Given this information, we have to find the length of the missing side and 2 of the angles of the triangle. Now, we cannot assume this is a right angle triangle. That information is not given in the question. We have to start by assuming it is an oblique triangle. Once we find the other measures of the triangle, we may come to the conclusion it is a right angle triangle, but to begin with, we cannot assume that. All right. Now, the first step would be to draw a diagram of the triangle using the information given to us and then labeling the angles and sides so it is easy to form an equation of the missing sides and angles. All right. So let's do that first. Here we have a picture of the triangle. I've marked angle B as a 55-degree angle. The side opposite angle A will be labeled with a lowercase a, and that has a measure of 4 units. The side opposite angle B will be marked with the lowercase b. We do not have the length of that side, and then the side opposite angle C will be labeled with the lowercase c, which has a measure of 7 units. Now, as you can see, this is a case of SAS. That means we have been provided information with the length of two sides of the triangle and the angle in between the two known sides. Now we will begin by first finding the length of side B, and then we can use that value to come up with an equation to find the remaining angles. So we will use the law of cosines to find the length of side B. Now the equation to choose from the law of cosines is the one which is to solve for B. So I'm going to now write out the equation to find the length of side B. The formula to find side B will be B squared equals A squared plus C squared minus 2AC times cos of B. We will plug in the values correctly over here. B is what we need to find, therefore we will write it as B squared equals, A has a value of 4, therefore 4 squared plus C has a value of 7, 7 squared minus 2 times 4 times 7. Cos of angle B is 55 degrees. Let's write that, cos of 55 degrees. Therefore, B squared will be equal to 4 squared is 16 plus 49 from 7 squared minus 2 times 4 times 7 is 56. Therefore, 56 times cos of 55 degrees. In the next step, I will find cos of 55 degrees. So we have 16 plus 49 minus 56 times cos of 56 degrees is equal to 0.5736. Therefore, B squared will be equal to, we'll first add 16 and 49, which should give us 65, minus 56 times 0.5736. We have to multiply 56 and 0.5736 before we can subtract that from 65. So that should be B squared equals 65 minus 32.12. Therefore, B squared equals 32.88. However, we have to find the value of B. Take the square root of 32.88 and we get an answer of approximately 5.73. Therefore, B has a value of approximately 5.73. I'm going to write it out here. B is 5.73 in the diagram, right? The next step will be to find the value of one of the angles. Let's begin by finding the measure of angle A. For this, we will have to use the law of sine. So this is a problem where we are applying not only the law of cosines, but the law of sines as well. I've written out the law of sines here. It's A divided by sine of A. Let me just rewrite it one more time. It's A divided by sine of A equals B divided by sine of B. We are finding angle A. Therefore, that is the unknown variable here. We know the value of A, we know the value of B from the previous step, and we know the value of angle B as well. Therefore, let's plug in the values. A has a value of 4. Sine of A, it has to be left as sine of A. B has a value of 5.73, and then we will have sine of 55 degrees for sine B. Now we are solving for sine A. Therefore, the equation to find sine of A will be A times sine of B divided by the length of B, which is 4 times sine 55 degrees divided by 5.73. Now sine of 55 degrees is equal to 0.8192, and then in the denominator we have 5.73. When you perform the calculation, you should come up with a value of 0.5719. That's the ratio of sine A. At this point, we have to use our calculators to find arcsine of 0.5719. that will give us the measure of angle A. Therefore, angle A would be equal to finding the arc sine of 0.5719, which should give us an angle measure of 34.9 degrees. And once we have the two angles, one of the angles is now 55 degrees for angle B, 34.9 degrees or 35 degrees for angle A rounded up. We can find angle C by subtracting the sum of these two angles from 180 degrees. Let's do that. So angle C is equal to 180 degrees minus angle A plus B. We will get 180 degrees minus 89.9 degrees, which is equal to 90.1 degrees. Rounded up to the nearest degree, angle C is a 90-degree angle. So we've just determined that this triangle is essentially a right angle triangle. Let's list all the lengths and sides of this triangle that we just found. On the side, the final answer would be side A is equal to 4. Side B, I'll just round it up. It's going to be 6. It was 5.73. So I'm going to round it up. It's going to be 6. And then C had a measure of 7. As far as the angles are concerned, angle A was equal to 35 degrees. Again, I'm rounding up to the nearest degree. Angle B equals 55 degrees and angle C is equal to 90 degrees. All right, so now we have solved for the triangle using the law of cosines as well as the law of sines. All right.